In today's video, we will discuss the resultant of the unbalanced forces, along with Newton's second and third laws of motion. Newton's second law of motion. To understand Newton's second law, we need to first understand what an unbalanced force is. Looking at the following examples, if you sit in a wheeled chair and ask your friend to push you along the hall, then the following two things happen. 1. If the push from your friend is stronger than the friction between the chair and the floor, then the chair starts to move in the direction of push. 2. When the push is removed, then the force acting on the chair is only the friction, which will decelerate the chair and the chair will eventually come to a stop. If the resultant force acting on an object is not zero, we say the forces are unbalanced. With this example, we learn that when there is a resultant force acting on an object, the object will accelerate in the direction of the resultant force. Newton's second law of motion describes the relationship between them as the resultant force, or F in Newton, is equal to the mass, or m in kilogram, times the acceleration of an object, or a, in meter per second squared. With this law, we can also infer that a. Resultant force of an object produces an acceleration. B. Acceleration is directly proportional to force. That means doubling the force on the same mass will double the acceleration. C. With the same resultant force, F, doubling the mass, m, will halve the acceleration. A. Newton's third law of motion. This law states that if body A exerts a force on body B, then body B will exert an equal and opposite force on body A. Thus, for every action, there is an equal and opposite reaction, and they act on mutually opposite bodies. This law can be understood with the following examples. When someone pushes an object, he will feel some force on his hand, as if the object is pushing him back. If a book is placed on a table, the book's weight, or the gravitational pull of the earth on the book, is acting downward. At the same time, the table's reaction force, or the normal force, acts upwards with the same magnitude. Hence, the book remains stationary, not falling to the earth. Newton's third law of motion tells us four characteristics of forces. 1. Forces always occur in pairs. Each pair is made up of an action and a reaction. 2. Action and reaction are equal in magnitude. 3. Action and reaction act in opposite directions. 4. Action and reaction act on mutually opposite bodies. Have you watched the video on Newton's first law and the concept of inertia? Find out more in our channel.